Okay, so we didn't have bell work today. I'm not doing it because there's so many people gone today, track meets and whatever else is going on. Okay, there seems to be a lot of people gone. So we won't do that today. But most of the questions that you guys have been asking me on these worksheets have been about which angle it is and which side it is it's talking about. By the way, the airplane one, it talked about, how did it word the one on the airplane, you guys, where it was going, here's the airplane up here. It wants to know the plane's angle of descent. Well, you guys, if I'm thinking about angle of descent, okay, the angle I'm thinking of is this angle right here. If I drew a line out horizontally from the airplane, the angle of descent would be the angle right there, right? That's the angle it's talking about. Now, how does this angle right here and this angle up here, how does this angle and this angle right here relate? They're not the same. They add up to 180 to 90 degrees. So we call them complementary angles, right? How much did it say the angle of descent was? Oh, that's what you're supposed to find out. What does it give us? 1,500 feet. Okay, so that's the vertical distance, isn't it? It's got to go descend 1,500 feet over a horizontal distance of how much? 9,000 feet. So you have those two figures right there, 1,500 feet and 9,000 feet. I would just find that angle right there, subtract it from 90, and you've got your angle of descent. Got it? Which is this angle right here. So sine, cosine, or tangent? Why do you say cosine? Why tangent? Yeah, we're given the two legs. We're given opposite side and hypotenuse side. So tangent is equal to opposite over, adjacent. We're given opposite side and adjacent side. So it's tangent equals opposite over adjacent. So tangent of x equals 9,000 over 1,500, right? And whenever you're looking for an angle, how do you put it in your calculator? Huh? Okay, you do second tangent. Well, if you're looking for this angle, right here it's 9,000 over 1,500. If you're looking for this angle, by the way, this angle and the angle of descent are the same. Why? Kobe, look, I might be answering your question right here. How did it say it again? How does it say it? Yeah, it's talking about the horizontal distance that you have to go to get to the airport. Okay, which number is it again so I can read it here? Which one is it, you guys? Number 3. An Air Force pilot must descend 1,500 feet over a distance of 9,000 feet. To me, that is definitely saying the horizontal distance. What is the plane's angle of descent? I don't know. I would say that it's talking about the horizontal distance it has to go. That's what I would say. I can see how you're thinking it sounds like the other, but okay. How many of you guys thought it was a horizontal distance? This one. How many of you thought it was this one? Okay. I'm thinking it's the horizontal distance right here. Okay? No, I can see. Yeah, yeah. Hey, Colby, I can see how you get that, but I think you and Alex have to take care of this outside of class. Alex doesn't seem too worried about it, though. Alex didn't even know there was a fight here. So, okay, I think you guys are good. We can move on. If you guys have any more disputes, take care of it out after class. No, I'm just kidding. All right. Okay, what? Okay, number 2. Wait, what? I think you guys can finish it from there, can't you? Okay. What was the other one you had a question on? 2. How tall is a bridge if a 6-foot tall person? Yeah, this one is the other one. How tall is a bridge if a 6-foot tall person? Okay, so here's the bridge. Hey, teachers can be wrong. I'm not saying, Toby, I'm not saying that I'm exactly right. To me, that's the way I'm reading it, and I think most people are right. Hey, we're all good, Colby. Okay, we're all good. Just fix it. So we all get the same. Okay, there's the bridge. Here's a 6-foot person. Who's a 6-foot person? Whose eyes are about 6 feet? Austin's eyes are probably about 6 feet. There's Austin. And he's looking up at the bridge, right? Okay, and it says, how tall is the bridge if a 6-foot tall person standing 100 feet away? So this is 100 feet. And we're going to say to the top of the bridge right there. Here's the height we want to find. Can see, okay, standing 100 feet away, can see the top of the bridge at an angle of 30 degrees to the horizon. Well, where's an angle of 30 degrees to the horizon? I would say, once again, it's this angle right here, right? However, look, you guys, this line is horizontal to this line, and those are alternate interior angles, so right here, that's 30 degrees as well, right? So you can think of that angle as being 30 degrees. Now, we want to know, when we say the height over here, we're going to really be finding the height from this point, where the 6-foot tall person is, to the top of the bridge, right? So what do we have to do to our answer at the end? Add 6 feet to it, right? Okay, so we're going to add 6 feet to this. Okay, so you guys got that? You guys can finish that one. By the way, which one would you use? Tangent again, because it's opposite side over adjacent side, right? Okay, so I think you guys can figure that one out. Okay, are we all in agreement it's not the hypotenuse we're looking for? Just kidding, Kobe. I was just kidding, totally. Okay, yes, Haley. Okay. Well, we're looking for this angle right here, so it's a tangent of 30 degrees. Well, we're not looking for that angle. We're given that angle right there. Tangent 30 is equal to opposite side, which we don't know, h over 100. Now, after I find out the answer to that, I got to add 6 feet to it, because you're taking the angle. Yeah. Because at the end right here, you're only finding the distance here. We got to compensate for you, Austin. Yeah. So that's why they gave you his height, is because you got to add the 6 feet to it at the end. Does that make sense? Okay, let's look at this. Hey, you know what? You know why I like story problems? Because they make you think about things in a different way. And really, if you guys think about real life problems, that's what they are. They're story problems, right? Real life math problems. Huh? People who need to know. Engineers. Curious people. Curious people. Yes. Well, they have tools for measuring, but you know what? You could take a protractor like this. You could take a protractor like this and tie a string at the 90-degree mark up here, and hold it down here so there's a weight down here. Okay, and as you turn this thing up like that, and you line it up along this line right here, looking up at your thing, the thing hangs down right there at the angle that you want. And there you have similar tools like that you can measure those angles. Because the bridge is so tall, he probably can't get up there to measure it. He can't. They probably have signs everywhere saying, "Do not climb this bridge." Hey, you know what was cool when I went to Europe, you guys? Um, they don't have all the they don't have the litigation that goes on there that we have in the United States, and so they don't have these warning signs everywhere. Well, it's kind of cool and it's kind of not cool, because they let anybody do anything, just about. You could in Europe when I went there, like in the United States they make you sign all these waivers and everything if you want to go down an alpine slide. I went down an alpine slide in Austria, and we could take our little kids on it. We could put them on there with us. We didn't have to sign any waivers. All we had to do is pay them money. If we get hurt, too bad. That's your fault, right? And so we would go down the slides. So it's way different there than it is here. Here you have to sign waivers if you want to go do something sort of dangerous, and they don't have anything that says don't climb this unless they don't want it to get hurt. They don't care if you get hurt, but they care if the thing gets hurt. So that was the only time I saw those things. But I kept wondering why, and my sister says because they don't sue here like we do in the United States. So anyway, all right, okay. Any other questions? Huh? Yes. We didn't learn anything about sin in here, Kai wants you to know. We learned about sign, though. Okay. Have you figured it out yet? Hey, you guys, really quickly, for Carly, Kai, and who else wasn't here that first day we talked about tangent rate? We talked about trig ratios. These are called the trig ratios. Okay? Write this down, Carly. You need to know this. Okay. If we have an angle, I'm going to call it angle A, right here. Okay? The tangent of A is just two sides of this triangle, one divided by the other. And the two sides that we're going to use is the side that's opposite of A, and the side that's next to A, we call it the adjacent side. So opposite over adjacent. And cosine of A, so from A, cosine is equal to the adjacent side divided by what we call the hypotenuse side. Remember, the hypotenuse is the side opposite the right angle. So it's adjacent divided by the hypotenuse side. It's just the length of the adjacent side divided by the length of the hypotenuse side. And the sine of A is equal to the opposite side divided by the hypotenuse side. And those are the three trig ratios that we learned about to solve problems. Because, you guys, if you have a 30-degree angle, it doesn't matter. If I have a 30-degree angle at A, it doesn't matter if I extend my triangle out right here, and if I take the tangent of that, this opposite side that's in black over that whole length, right there, the adjacent side, is equal to this opposite side over this adjacent side right here. It's the same ratio, and that's why this works. Okay, so these are the trig ratios. You guys need to remember them, memorize them. And I gave you guys this little acronym for remember them. SOHCAHTOA. So those of you who weren't here, sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Right there. Okay, so got it? Watch my video. I did a good job teaching it that day. We spent a lot of time on it, okay? Huh? You just learned this last night. Yeah. What? What were you saying? Okay. Oh, no. That was dividing segments in certain ratios. That was that stuff. Okay. All right. This stuff, no, I've been teaching this for years. We use this all the time. You guys will use it a lot, okay? All right. Are there any other questions on that? Okay, just really quickly, I'm going to help you set up 4 and 5. An eagle spotted a mouse 20 feet below at an angle of 42 degrees with the horizon. Okay, so here's the eagle up here flying. I'm not very good at drawing eagles. There's my eagle, okay? All right. Spotted a mouse 20 feet below at an angle of 42 degrees with the horizon. So he's looking down at this mouse that's down here. Okay? Oh yeah, mice have good tails. Okay. Do mice not have curly tails? Okay. I've never been known as an artist. I can't remember things like that. Okay. So, I believe Colby is correct on this one. When it says an eagle spotted a mouse 20 feet below, so 20 feet below at an angle of 42 degrees with the horizon. Now, you guys, if you think about, here's the horizon, here's the angle that he saw, 42 degrees, right? Which, if you think about it, is the same as this angle right here, because this line is parallel to this line up here, and this is like a transversal going to it, and this is a pair of alternate interior angles, okay? We're supposing the ground is flat on this, okay? If the eagle flies along its line of sight, how far it will have to fly to its prey? When an eagle goes after its prey, it doesn't go like this and then sneak up on the ground, right? It goes right down its line of sight. Right, Colby? Okay? Because some of you guys didn't have that one right. This time he flies right down here, okay? So he flies right down his line of sight and he gets that thing. Okay? So we know once again that's 90 degrees right there. So this angle is 48, because 42 plus 48 makes 90, right? So you can use whichever angle you want here in this triangle, and you have this side right here, okay? So which angle do you guys want to use? If I use 42, that's the side I want to find. 42, I have opposite, and I have hypotenuse. So which one do I want to use? I could use sine equals opposite over hypotenuse, but I think I'd rather use cosine. No, either way, cosine of 48 degrees, but yeah, it doesn't matter. Sine of 42 degrees equals opposite side over hypotenuse. If you solve that for x, you would get x equals 20 over sine of 42. Do you guys all understand why? We did several of these the other day. Okay, because I would times both sides by x, those would cancel out. Well, if I did this angle right here, I could do cosine of 48 degrees is equal to adjacent over hypotenuse. Do you remember the other day, you guys, that we learned that the sine of 42 degrees is equal to the cosine of 48 degrees, since 42 and 48 are complementary angles? It's the same. You can see that in the picture right here. So either way you do it, you're going to get it right. And this would be x equals 20 over the cosine of 48. If you put either one of those in, you would get the same answer. 20 divided by the sine of 42, 20 divided by the cosine of 48. Make sure your calculator is in what mode? Degree mode, because in my pre-calculus class we've been working in radian mode, so they've been switching it back. So make sure you check your calculator. Yes. Yeah, we can. Okay. You guys, I'm just going to help you draw the picture on number 5 really quickly. In a movie theater, 150 feet long, the floor is sloped so that there is a difference of 30 feet between the front and the back of the theater. What is the angle of depression? So here's the floor of the theater, right? Here's where you walk in at the back of the theater. Here's the screen down here, right? Okay. What's the vertical distance, you guys? 30 feet. All right, which one do you think it is? Do you think it's the hypotenuse they're talking about or the horizontal distance? In a movie theater, 150 feet long. Yeah, I think they would measure a movie theater from there to there, right? So I would say that too. I think it's the same as that other one. And the angle of depression, you guys, is this angle right up here, isn't it? Which is the same as that angle down there, right? Same problem as before. Opposite and adjacent, which would be which thing? Tangent, right? All right, which number did you want to go over on that other one, Colby? 7. Okay, 7. Oscar's doghouse is shaped like a tent. Here is Oscar's doghouse. The slanted sides are both 5 feet long. 5 and 5. The bottom of the house is 6 feet across. What is the height of his doghouse in feet at its tallest point? So it wants to know that distance right there, right? Let me ask you this. How long is it from right here to right here? It's how long? 3 feet. You know what? With this problem, we're making a lot of assumptions, but I think the assumption we're making is that when they built the doghouse, well, actually no, because that's an isosceles triangle. We're not making an assumption there. So we can say that that distance, because this is called a median of a triangle, right? And a median is also, on an isosceles triangle, is perpendicular to it, and it hits it at its midpoint, so it's 3 and 3 right there. So do you guys see how to finish that one now? You got the hypotenuse, you got one of the legs, you got to find the other leg. Use the Pythagorean theorem to find it out. Okay. All right, let's correct these. You know what? You know what we'll do? I'm going to make this due next time. I'm going to make this due next time. We'll correct it then. Okay? Because I want to move on. Okay, we will be having a quiz next time, you guys. I was going to have it today. There's too many people gone, so I'm going to have it next time. Okay, listen. This is what the quiz will be on. It will be on if you have a triangle. And you put a line through the triangle that intersects two sides, and if it's parallel to the third side, okay, then it divides this triangle into ratios. What are the ratios it divides it into? What's the ratios it divides it into? X over y is equal to z over r, right? That's one ratio you can divide it into. Or you could divide it into x over x plus y equals z over z plus r. In other words, x over this whole length is equal to z over this whole length, right? Okay? And also, this is s and this is t. You can also say that s over t is equal to x over what? S over t is equal to what? X plus y. Someone said, good. Okay, because those are both, because you remember it makes two triangles, two similar triangles in that case, okay? So you're going to have to solve some proportions with that. Do you remember that, doing that? Okay. Also, if I have two triangles, and I have this angle congruent to this one, and this angle congruent to this one, and I know that this side is 5, and this side is 15, and this side is x, and this side is 22. Do you know how to solve that? Find x. Okay, this will be on the quiz. So how do I do that? What's the proportion I would write? You could write 5 over 15 equals x over 22, or you can do 5 over x equals 15 over 22. Either way, you're timesing the 5 by the 22 and the x by the 15, right? Okay, so that will be on the test, the quiz. I might do that as an extra credit problem. Okay, for those of you who learned it. Okay. Okay, so those of you who learned how to prove the Pythagorean theorem using similar triangles, remember there's that Khan Academy video we watched. You can re-watch it on there. Okay, then we are also learned about dividing segments. Okay, if I gave you two points on a line, A at 5, 12, and B at -3, -4, and I said, find point C, so that it divides AB into the ratio 2 to 3. Remember how to do that? Yes. Okay, do you have that in your notes? Can you study that? Okay, this is the equation again. You should have it in your notes, but in case you don't. By the way, Austin, this is the thing I was saying that this is the first time I ever taught this. Okay, yeah. We're going from A to B, because this is written A, then B, right? And so we're going to take point A, and we're going to put x of point A right there, and y of point A right there, plus, what's the ratio we're going to use? 2 over 5 times by, and that ratio is obtained by going 2 over 2 plus 3, which was 5, okay? And plus what? The horizontal distance between A and B. You can find that by just taking your x numbers and minusing them. 5 minus a negative 3, right? Which is 8. And then your horizontal distance, because y's have to do with the horizontal distance, right? So 12 minus a negative 4, which is 16, right? 12 minus a negative 4 is 12 plus 4, which is 16. Okay, and so if I put that in my calculator, what does x come out to be? What? 8.2? Anybody verify that? Okay. What does y come out to be? What was that? 2. 18.4? Really? Oh, well, you know what? Yeah. Well, actually, think about this, you guys. 5 comma 12 is going to be up here somewhere, right? And negative 3 comma negative 4 is going to be down here somewhere. And so I forgot, if I'm going from A, which is right here, down to B, which is right there, I'm going backwards right there. So I've got to do this the other way around. Yeah, so I believe that should have been a negative 8 and a negative 16, right? What would that make it? What'd you get? 1.8? And what's this one? 5.6? That sounds more plausible, right in there. 1.8, 5.6. I mean, I don't have this. We could graph it and see if it looks right. Should we graph it really quickly? We're gonna put this down here. 5 comma 12. 1, 2, 3, 4, 5. 12 would be about 1, 2, somewhere right in there. And negative 3, negative 4. 1, 2, 3, 1, 2, 3, 4. That's B. That's A. If I do that line there, 1, what was it we came up with? 1.8, comma, 1, 2, 3, 4, 5. Does that look like 2 and 3 right there? Pretty close to it? I think that looks pretty close. Okay. All right. Okay, that's dividing a line segment. We'll have that on the test. And then, wait, yeah. So that's what's going to be on the quiz. You guys got it? Well, maybe I ought to just combine the quiz. Yeah, let's do sine, cosine, tangent on there too. I might put a story problem on there, yeah. Hey, story problem's where it's all at, you guys. I want you guys to draw the picture. We'll challenge you a little bit. I think I might make it into a test. Make a 3x5 card. Everybody hear that? Make a 3x5 card. Make a 3x5 card. I'm going to make a test. 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 3x5 card. Prepare one. Okay. What is the radius of this circle? 1. It is 1. Okay. It is 1. Okay. That distance from here to there is 1. Okay. Now, if I put a point out here, let's just say right there, and I drew, and I want to know, I'm going to know the coordinates of that here in just a second, but if I drew a line straight down, a line from here up to there, a line right here, I have this angle. I'm going to call it angle theta right here. Theta is a letter in the Greek alphabet. We often use it in trigonometry. So when you do trigonometry, you'll see theta all the time. And this forms a right triangle right here, right? How far is it from here to here, everybody? 1. Okay? And I want to know, and this right here is the x distance, right? And this distance right here is the y distance. Everybody got that? Now, okay, you guys watching this? This is really important. This is what we're learning today. Okay? If I want to define the cosine of theta right here, okay, by definition, what is the cosine of theta? Adjacent over hypotenuse, right? Which side is adjacent right here? X. Which side is hypotenuse? 1. So by definition right here, cosine is x over 1, right? Okay? What about sine of theta? Yes. Wouldn't y be 1? Is y, is this distance right here, is that a radius of a circle? Think about this distance right here. That's the radius of a circle. That's why we know it's 1, right? And on a right triangle, what's always the longest side? The hypotenuse. So y is not as long as that. Okay? Okay, if we were defining sine right here, you guys, what would sine be? Y over 1, because it's opposite side over hypotenuse, which would be y over 1. Now, x over 1 is just equal to x, and y over 1 is just equal to y, right? So we have this now. Cosine of theta equals x. You guys, this circle right here is called a unit circle. This is your first introduction to it. Next year, when you take Secondary Math 3, you'll learn more in depth of it. But right here, you guys, over on the sides, I have a unit circle here and a unit circle over there. And we define some special angles on the unit circle, like 30-degree angles, 45-degree angles, 60-degree angles, and 90-degree angles. And then those same angles in each of the other 3 quadrants. And then we tell what their x and y coordinates are. We'll learn more about that later on. That's not what we're doing today. What we're learning today is that cosine on a unit circle is the x coordinate, and sine is the y coordinate. Do we understand that? So whenever you guys see x coordinate on your circle, think of cosine. Whenever you see y coordinate, think of sine. Okay? So we're going to relate that to the Pythagorean theorem right here. X squared plus y squared equals, well, hold on. A squared plus b squared equals c squared, right? Now, we're going to make some substitutions on here. Okay? Right here, we can substitute for a, we can substitute what? X. So we're going to write x squared. What can we substitute for b? Okay, y squared. And what can we substitute for c? 1. And 1 squared is 1 right there, right? Now, since we just learned that x is the cosine and y is the sine, can we substitute those in there? We're going to put theta. Cosine x is equal to cosine of theta, right? So we substitute that in there. Y is equal to sine of theta, right? So we substitute sine in for y, and equals 1. I want you guys to see this right here. We call this a Pythagorean identity. We call that the Pythagorean identity in trigonometry. Now, one thing that's really different about teaching the secondary math 2 class than compared to when we'd teach this in a trig class or a pre-calculus class is that I'm teaching you one identity here. And usually we teach you all the fundamental identities together. I don't know why we're just teaching one, but I'm going with the flow here. I guess these guys know what they're doing. And we'll add on to it later on. They just want to touch on it right now. You need to know that identity, but I am going to add one more because there's one other identity you need to know, okay? We also know that tangent of theta, and look right here, here's theta. Tangent is equal to what over what? Opposite, which is y, over adjacent, which is x. Y over x, right? And we know that y is the sine and x is the cosine, so I could rewrite this as what? Tangent of theta equals sine of theta over cosine of theta. I need you to know that identity for what we're doing today as well. That's called a quotient identity. What does the word quotient mean? Quotient identity means what? Division, right? And we're dividing sine by cosine, which is the tangent, okay? I need you to know those identities. There's actually 2 more Pythagorean identities. There's 1 more quotient identities, and there's what we call 3 reciprocal identities. And I don't know why we don't teach them here, but I'm not going to spend time teaching them since you don't need to know them yet. I'm guessing that that will be taught at a later time. Okay, now what we're going to do is we're going to use these identities to solve some problems. Okay, let's say, by the way, this is one of the things you're supposed to do is prove that the Pythagorean identity is true, and we kind of just did that using the Pythagorean theorem and using a unit circle combined to come up with the Pythagorean identity right here, okay? So we did that. The other thing you're supposed to do is you can find the sine of theta, the cosine theta, and the tangent of theta given sine, cosine, or tangent between an angle between 0 and 90 degrees. So that's what we're going to do next. I'm going to do an example problem. Okay, we're given the following information. We're given that the cosine of theta equals 4/5. And that we're in quadrant 1. In fact, every problem we're going to do, you guys, is in quadrant 1 because that's what the curriculum is telling me to teach you. When you get later on, we'll learn if they're in 2nd, 3rd, or 4th quadrant some other time. I don't know when. It's in your curriculum at some other time. Okay, so we're given an angle. Now, I can draw a picture of this, of a cosine in the 4th quadrant. I mean, in the 1st quadrant. By the way, the hypotenuse, so since cosine is equal to adjacent over hypotenuse, the adjacent side would be 4. I'm going to do it like this. 4. And the hypotenuse would be 5. So it would probably look more like this. So that would be 5. And then we would have to find this length over here using the Pythagorean theorem. Okay? But I'm just going to show you right here, using the Pythagorean identity, how we can solve a problem like this. We just learned that the cosine squared of theta plus the sine squared of theta equals 1, right? I want you, given cosine of theta equals 4/5, I want you to find sine of theta. How could I do that? How could I find sine of theta using the Pythagorean identity? Say that again. Yeah, but it's squared, yeah. But you're on the right track. this is what we can do, you guys. See this cosine? Since we're given cosine as 4/5, I can substitute it in there. 4/5 squared plus sine squared of theta equals 1. Could I solve this for sine of theta? And then would I have my answer? Because I'm looking for sine of theta, right? So let's do that. What is 4/5 squared? What's 4 squared? You guys don't need your calculators. 16. What's 5 squared, everybody? 25. You guys know those, right? What am I going to do next to get sine by itself? Minus what? Minus 16/25 from both sides, right? Because I want to get rid of the 16/25 over here, and it's being added sine squared. I do the opposite. I'm minus 16/25. If I do that, I'm going to get sine squared of theta equals 1 minus 16/25, right? What's 1 minus 16/25? I don't want to do it in decimals. Think about this, you guys. If I'm going to subtract right here, I got to get a common denominator. So what am I going to change 1 to? 25 over 1 is 25. 25 over 25. 25 over 25 is 1, isn't it? And it now gives me the denominator same as that one. Now I can subtract. What's 25 minus 16, you guys? 25 minus 16 is 9. So I get 9/25. Now I've almost got sine by itself. It's still being squared. What do I do? I take the square root of it. Now, normally when you take the square root, you get plus and minus. However, I know that my angle is in the first quadrant. That's why this is important, you guys, up here. And everything, x and y, are positive in the first quadrant. So I just need the positive one. So sine of theta equals the square root of 9 is 3. The square root of 25 is 5. Right there. And there's the sine of theta. I'm going to show you a faster way to get it. But you guys are actually, this is the information I'm giving you, you're supposed to do it this way. But let me just show you. You know how we drew this picture right here of angle in this quadrant? If cosine is 4/5, that means the adjacent side is 4 and the hypotenuse is 5, because the cosine is equal to adjacent over hypotenuse, right? If I use the Pythagorean theorem and I went 4 squared plus, we're going to call that y squared, equals 5 squared, and I solve that, guess what I would get? I would get 3. And now I can say, well, since this is theta right here, because we got cosine of theta is 4 over 5, sine is equal to opposite over that, and so sine would be, theta would be equal to 3 over 5. That's another way to do it. Yeah, the circle, this symbol right here means theta. Okay, it's the letter in the Greek alphabet. It's just a variable. Okay, that's what we're doing today, you guys, right here. You're supposed to solve it like this, though. Got it? I do want you to solve it like that, because that's what the curriculum shows us. They're going to be adding on to it later. If you don't know how to do that, later on you might get yourself stuck, okay, somewhere else, not understanding something else. So I am going to give you 3 problems to do at home for a homework assignment. Write them down right here. Homework. I'm going to put theta is in first quadrant. That means everything's going to be positive. Does everybody understand that? You're not going to have any negatives. Given sine of theta equals 2 over 5, find cosine theta. Okay? Number 2, given cosine of theta equals 5/6, find Oh, you know what? I didn't even need to show you that tangent one. Okay, given sine of theta equals 1/4, find cosine of theta. That is your homework assignment. Okay? Now, you guys, I didn't give you as nice a numbers as I gave the example we did. You're going to have some square roots, like square root of 6, which is not a perfect square. Just leave them like that, or simplify them, one or the other. But don't turn them into a decimal, okay? I don't want decimal answers. Want me to do one kind of like that so you guys can understand that? Do you all have them written down? I want you to try some of these yourself. I want to do one of these where it's not such a nice number. I'm going to do cosine of theta equals 3/4. We're given that cosine of theta equals 3/4. I want to find sine of theta, okay? You guys ready? Okay, I'm going to use cosine squared of theta plus sine squared of theta equals 1. What do we call this? Pythagorean identity, okay? By the way, an identity is true for any value of theta. That's why we call it an identity. It's an equation that's true for any value of theta. Okay, it's just that theta and that theta have to be the same number. Okay, now, I'm going to substitute for cosine of theta. I'm going to substitute what? 3/4. So I have 3/4 squared plus sine squared of theta equals 1. What's 3/4 squared, everybody? 9/16 plus sine squared of theta equals 1. Okay? Minus 9/16 from both sides, and I get sine squared of theta equals 16/16 minus 9/16. I kind of skipped a step. Do you guys see what I did? I just changed the 1 to 16/16 without, right, when I minus 9/16 from both sides. What's 16 minus 9, you guys? 7. So I get sine squared of theta equals what? 7/16. Now, here's why I say this is not as nice a number right here, is because when I take the square root of 7, because now I'm going to take the square root of both sides, right? Sine of theta equals the square root of 7 over what? 4, because the square root of 16 is 4. And that's my answer right there. So I don't want you changing that. I don't want you guys changing that to decimal. I want you to leave it as square root of 7 over 4. Got it? Can you guys handle that? Okay. So the previous 3 problems are your assignment. Have at it.